Okay, good afternoon, everyone, and welcome to the STEM Lockdown Digital School. This is Coding for Grade 7, and I am your presenter, Mr. Paul de Klerk. And there you can see my email address on the screen. So if you would like to send me any questions, maybe I discussed something that you want to know about and you didn't have a chance to ask during the lesson, or you're watching the live stream and you've got any questions, you can feel free to send me an email there. As well as I'd like to see the code that you guys are writing. Sometimes we have some puzzles or activities where it's open for us to do different things. You're not limited or restricted to what you can do. So if you create something cool, share that with me. I'd like to see it. Right, I just quickly want to see here if we have any new people here. Okay, I see a few new names. Gao is here. He's been here a couple of times. Welcome. If you are new and you are feeling lost, don't worry about it. Many of the puzzles are difficult, and then once we start with a new lesson, then we go back to easier stuff in the earlier puzzles, right? So we're doing Minecraft today, so the first few puzzles were really easy, and that'll help you to catch up. I will also share a link with you, and then after the lesson, you can just save that link somewhere, copy and paste it, save it somewhere, then at your own pace, you can go into that link, and I'll show you how to navigate back to the first lessons. So then you can sort of catch up on your own and play with the system until you are caught up to where we are. But please feel free, the chat box is there so that you can ask questions. And on that note, it is there for questions and for me to answer. It is not there to chat with your friends about random stuff and things that are not applicable to the lesson that we are on. So all of that being said, try to keep your cameras off. I know accidents happen, but let's try to keep that at a minimum. When you switch on your camera, I cannot see my screen and then we are lost. So let's get right into it, right? So those that have been with me before, you know that I complain about this every day. Coding principles. Now, the reason that why I have coding principles on here is I want to create a foundation for you that you can use to learn any coding language on. So these principles are not just relevant to what we are doing here today. I code in 4 different coding languages, and these principles are applicable to all of them. Okay. So the one we are on teaches us about JavaScript. It's based on JavaScript, but as I said, these principles you can go and apply to other code as well. So let me just get into them right at the moment. So the first one is we want to identify the goal, especially now where we are having bigger and more difficult puzzles. We have to try and really find out what the goal of the puzzle is, and then try to aim for that. It's very easy to just get stuck into moving the character around and not really focusing on what the character has to do at each part of the maze or the map or whatever they're on. The next one is we want to follow the problem solving workflow, and that workflow is we want to, oh, sorry, I skipped ahead. So what we want to do there is we want to take that goal and we want to break it down into smaller problems. And we want to first try and solve the smaller problems. Then we create a solution for the smaller problem. Then we test that solution, and then we adjust the solution if we need to, right? So it's identify, create, test, and adjust. And then you just repeat that workflow over and over until you have a nice sequence of code that does what it's supposed to do. And then lastly, we want to apply information management practices. So you'll see there, and I've showed this to some of the guys before, and I'll show it to you again. If there are comment blocks for us to use, we have to try and use them, okay? They help us to just arrange the information in such a way that we can actually read it if we need to go back to it. And if somebody else needs to come and debug our code, then they can do that as well. Okay, let's move on. So today we are in lesson 13, conditionals in Minecraft, Voyage Aquatic. This says puzzle 7 to 11, but I think we are a little bit behind, but that's cool. It gives us time to catch up our new friends. So I'm going to jump to the coding screen. And yes, there you can see we are on lesson number 5. So I'm going to revisit that one, and I will share the link in a second for you guys. Okay, there we go. So in the chat box, the link is there. Please, if you have that open, oh, I see Junior's here. Welcome, Junior. If you have that open, just type a yes for me in the chat box, and then we can get started with this puzzle. And while you do that, I'm just going to take a sip of water. Gao is ready. Junior, are you good? Can we get going? And Bule seems to be our other friend. Okay, because we are also going live, I can't wait for everyone to send me a message in the chat, so I'm going to get going. I think if Gao got it, then most of you would have gotten it as well. So we did this one yesterday. For those that are new, I'm going to run through this platform once very quickly, and then we get started with coding. So the first thing to notice is this is lesson 13, and you can see when I hover on it, my mouse pointer turns into a hand. Now, whenever that happens on a computer, especially on the internet, it means that something is clickable. So when we are finished with this lesson and you've saved this link up here in the address bar, you've saved that elsewhere, you open that link and then you can come and click here. And when you click on that, you will be able to navigate to all the lesson extras as well as the first lessons and the puzzles that we've already completed. Okay, so once you've noticed where we are, then you can see here, these are the amount of puzzles that are available in this lesson. They differ. Sometimes there are only 6, other times there might be more than 11. It's all going to depend on what you're going to be learning in each lesson. And then here you can see this little flag, and that says lesson extra. So I have activated, I created a section for you guys to work from. And this link in the address bar leads to that section, and the extras are activated. So you can go and do the lesson extras. And I advise you to do them as homework on your free time, because we don't have time to run through them all during the lesson, but they are very good practice. Right, so now getting into the coding in itself, here are the instructions. So I remember I said we need to identify the goal of this puzzle, and then we need to identify the problems, then we need to find solutions. So all of that basically gets done up here, and I'll show you what I mean by that in a second. Over here we have the play area, so whatever we code is going to happen here. We can see whatever we do being acted out in this space here. You can adjust it to be bigger or smaller. When we are working like this, I like to make it relatively big. And under that, we have a run button. Now this run button is linked to the when run block that you have in your workspace. I'm just going to remove this. Each puzzle that you start will have this already installed. And you can see there it uses up 1 block worth of space in your workspace. And the reason for this is this button activates whatever is touching this block. Okay, without this when run block, or without this button, we can put all the code we want to in the world here and nothing is going to happen. We need to have them activated by some way or some manner, and this is what this button does through the functioning of that block. So whatever code we put needs to touch that block, otherwise it won't work. Right, so next to that we have the toolbox, and here we have different types of blocks that we can use. I'm not going to explain them now, we will talk about them as we progress. And here we have the workspace, and this is where everything happens that we do. Like in this one, we have a restriction of 5 blocks, so we're not allowed to use more than 5 blocks, which in effect are actually only 4 blocks, because the first one is the when run button, or the when run block connected to the run button. Okay, so let's get into this problem. So there's a Nautilus shell hidden somewhere. Explore the shipwreck to reach the chest. So the goal of this puzzle is we need to reach the chest. Okay, so the first problem that we have is we need to move Alex towards the chest. Okay, so now we identified the problem. Now we work on a solution. So I always advise my students to first start with the sequence before we start repeating anything. Okay, and the reason for that is if you have this in a repeat and there's a mistake, it's much more difficult to identify the mistake when the code is looping. When it's not looping, it's a plain sequence like this, it's easier to see where you went wrong. So the first one that we had yesterday, somebody told me put a turn right because they want Alex to swim this way, then move forward twice, 1, 2 times. That's going to line Alex up here. And then we can see if Alex does this again, she's going to move towards the chest. Now, there are two ways. We can either write this code again by saying turn right again and putting 2 move forwards again, but then we run out of space here. We are using more blocks than we are allowed to use. So we remove this, we put this entire code into a loop, and this loop is a conditional loop, meaning it will repeat until this condition here, this statement is true. So as long as this statement is false, this loop will run. So previously we had repeat blocks where we could set how many times we want a repeat to happen by using a number. And that would tell the code to run 3 times or 5 times or 12 times. We even had one where you could have gone 144 times if you wanted to. This one is not set that way. This is a conditional loop, and what a conditional means is as long as this statement is true, this code will run. This block, the repeat block, will function. Okay, as soon as this is false, meaning that it has been met, then it'll stop working. Okay, right. So if we run this, we can see Alex turns, Alex swims in front of the chest, and the Nautilus shell is found. And they pointed out to me yesterday, this is a toggle, so you can set different things. If we went left, the same thing happened. We actually found this by accident yesterday. And again, the Nautilus shell is found. Right. So are you guys ready? Do you understand that? Can I move on? Go to the next puzzle. I think that you should be good. Bule, you can write in the chat box if you'd like to. Can I move on to the next puzzle? There's a yes. Okay, so let's keep cracking on. Okay, good. So first things first, we read the instructions. Looks freezing out there. Catch a salmon on your way to the underwater ruins. Okay, so this looks freezing out there has nothing to do with what we need to do, but it does create some restrictions because now there are ice blocks and we cannot move through them. We have to move past them. Okay, and then this is the main goal of the puzzle. We need to catch a salmon, right? Catch a salmon. And for those that don't know, salmon is a type of fish. And there we can see the fish jumping in and out of the water. So in order for Alex to catch the salmon, her boat needs to be on top of the salmon. Okay, not next to it or behind it. It needs to be on top of the salmon, right? And now we see another restriction. We only have 10 blocks. So we need to complete this puzzle in 10 blocks. So in my opinion, the first step is to identify the smaller problem within the bigger goal, and that is to move Alex from here to there. And we're not using repeats and things just yet. Okay, so let's see, how would we go about doing that? In the chat box, quickly tell me. I actually think there's a shorter way to do this than 10 blocks. So let's see. Gal, what would the first block be that I need to use in my workspace? Any ideas? Okay, we don't have many students here today. So if you're viewing this on the live stream, I want you to head over to Africa Teen Geeks' website, right? It's Africa Teen Geeks. Just put that in Google. You will find the website. Ask your mom or dad to register. They will receive an email that contains the links to all of our lessons. Okay, so if you're watching this on a YouTube live and you would like to be here with us in this lesson so you can ask me questions and give me answers and input in the chat box, that's the way to do it, right? After you've received the link, you click on it, Zoom will download to your computer, and we will give you access so that you can come in here with us. Right, so that being said, let us just get going. So the first thing I can see is Alex needs to move the boat from there to there. And if I have to just estimate, it looks like 3 blocks. So we're going to make a move forward 3 blocks. Okay. Now, this is going to move all the way there. But there is a shorter way to get 3 blocks working. If we use a repeat block and we loop move forward 3 times, there we go. Thank you, Gal. We get the same thing. The difference is now we're using only 2 blocks. Remember, the first block is when run. If we do it this way, we're using 3 blocks. So you can see we're limiting ourselves to what we can do. So we remove that and we use the repeat block. Now that Alex is there, remember we test the code so we can see where we're at. We can see Alex needs to turn to the right. So we make Alex turn right. Okay. Now Alex needs to move 1, 2, 3 blocks again. So we'll do that with another repeat. 3 times. And at the end of this, Alex needs to turn left, right, to go upwards. Remember now, the way Alex is orientated on the map, Alex is looking towards the workspace. So to go left, or at least to move up, means turning left. To come down means turning right. So let's test this code and see where we get it. Okay, so we're there. We cannot continue straight because that turtle will stop us, so we have to come around this way. So now there are 2 options. Either we need to write this piece of code again, another move forward, turn right, and then a move forward, repeat 3 times. And we're not going to be able to do that because we are already sitting on 7 blocks. But by adding 1 repeat here and nesting this inside that repeat, this is what is known as a nested loop, is a repeat in a repeat, okay, or 2 repeats inside a repeat. Now I think we should be able to get it done in less than the 10 blocks that we were allocated. And look at that. Okay. So that's the power of the conditional as well. If I can just go back to that, I want to show you something. If we were using, just take this out, a normal repeat loop here, we would have had to calculate using maths or taking our mouse pointer on this maze and actually trying to act out the way that Alex will move. How many repeats to use? And if we put too many repeats, what would happen is Alex would get here, then turn up again, then go here again. But it's wasted code. We don't need that. Alex only needs to reach this point here. Okay, so even this last turn left is actually being wasted, right? Or we might accidentally put this at a lower number. So for now, we can see twice is enough. But let's say this was a bigger map and the code would have had to repeat 5 times, but we accidentally put in 4 times. We would fall short because we wouldn't get to our goal. But using a conditional, we do not need to calculate how many times we want this sequence. This whole thing is a sequence now. Even though it has repeats in it, it becomes a sequence. We do not have to calculate how many times to repeat because this is saying while this goal is not met, so I want to rephrase what I said earlier, while this one is false, the code will keep repeating. As soon as this one is true, so the goal has been met, then the repeat will stop, okay? So earlier I mixed those 2 up because for another conditional, it's a different way around. But for a repeat conditional, while this is false, the code will loop. Once it's true, the code will stop looping. So we don't have to calculate anything and we don't have to guess or experiment with anything. If we have that in there, it has to work. And because we did our sequence and tested that, we know we're fine. Right, so what do you guys think? Can I move on? Go. Next puzzle. Oh, before I do that, let me just drop this link in here. I think we have some more students who have joined us. Welcome. Okay, we don't watch videos here. We're here to code, so we take that video off. If you are doing this on your own, not through the lesson, then you're welcome to watch the videos. But believe me, if I'm here, you don't need those videos. Okay, so let's see. You found the underwater ruins. Again, as far as what our goal entails, this doesn't mean anything to us. This just tells us a bit about what's happening here because they're trying to make it a bit more fun for us, okay? And for those that have played Minecraft before, it is exciting to find these ruins. There are always chests hidden there with some treasure in it. So what we want to do is we want to search the sandstone. That's this structure that it's been built of, containing for a chest containing a prismarine treasure. Okay. So we want to search this maze until we find that. So the actual goal is we need to search for a chest. Whatever's in the chest doesn't really relate to what we'll code here at the moment for this problem. Maybe in future problems it will, but for this one it doesn't. So our goal is search for the chest. And we need to break that into smaller problems. And then also we need to notice there is a new conditional block here. And they've already put it for us in place. I'm removing it so that I can show you what that will do. So what this is saying is if this becomes true, if there is a path to the right, then do something, okay? Now that can be if there is a path I want you to move forward, if there is a path I want you to turn right, or I want you to turn left, okay? The same with this conditionals toggle can also be set to something else. If there's a path ahead, then move. If there's a path to the left, then I want you to act in a certain way. So all of this becomes a conditional that tells us if this is true, then you do that, right? So I hope that's clear. So the way they had it was move forward until the goal has been reached. So we don't want that necessarily. And now I see this and I see a turtle there. So I wonder, I can't remember, I did this one quite a while ago, if we can move past this. So let's try that first. So we're going to say move forward, and then if there's a path to the right, turn right. Okay, right, so we can see there, if there's a path to the right, we want you to turn right. So let's run that and see. Okay, there's a path, so it'll turn. Okay, so we can swim past that. The other thing is we don't have to count how many times to move forward because this is a repeat. So until the goal has been met, the move forward will happen. And until the goal has been met, once the move forward can no longer happen anymore, or this statement, there is a path to the right, becomes true, then the code will jump to this one. And that once this has been executed, it repeats back as long as the goal hasn't been met. So it will run this code, jump, repeat, run the code, repeat until the goal has been met. Okay, and again, we're doing it in 5 blocks where we have 7. So let's see whether we will find the Nautilus shell in this way. I'm not sure if we can reach the Nautilus shell from the back. And yes, we can. Oh, it's not a Nautilus shell, sorry, it's a prismarine. Important thing is the chest. Okay, so we want to reach the chest and we can open the chest from the back so we can get the treasure that is inside. Right, so just to talk through this again, right? So if we want to break this up into smaller problems, problem number 1 is we want to move from there to there. So we know we're going to use a move forward. Now we can count 1, 2, 3, 4, 5, and we can put 5 move forwards. But if we do that, we very quickly realize, there we have 5, that we're already using 6 blocks and we still have to do 2 turns and get to here. So this is not a viable option. We do not have a repeat by number block here. We only have a repeat until goal block. So we're going to use that conditional repeat. Okay. Now we can see that we're moving forward, right? So what becomes the problem here is, I don't know if you saw that, but Alex keeps bumping her head against that. She doesn't stop once the road ends. She just keeps going because it says move forward until the goal has been reached. So as long as the goal hasn't been reached, she will try to move forward, even though there's an obstacle in the way. So we need to find a way to make Alex turn right. We can't just use a turn right, because now what's going to happen is we're going to move forward one block and turn right immediately. You see there? So Alex is just going in this crazy pattern the whole time, because it's move once forward, then turn right one time. Move forward one time, turn right one time, and do that until the goal has been met. So this will go on forever because the goal is never getting met. So we need to find a way to say, okay, only turn once it is okay for you to do so, once there is a path for you to turn into. And that we do by using this if conditional. The if statement is saying, if the path is there, if this statement is true, then do that. As long as this statement is false, it'll just keep repeating this. So the code, actually, you won't see it with your eye, but it runs from move forward to this, move forward to this, repeats, move forward to this. So what happens is it's a move forward, then check, it's false. Okay, we go back. Move forward, it's false, we go back. Move forward, it's true, now do this. Then we go back until the goal has been met, because that's what the goal says there, or the top loop says, the conditional loop. Okay, do you guys understand? Do you follow? Are you happy? Can we move on to puzzle number 8? Bule says yes, good. In JavaScript, loops are extremely important. Not only loops as in repeat one time or two times, loops as in conditional loops like we have here, repeat until something. They're really important, they're very powerful. And this game, Minecraft, one of the main coding languages that was used or is still being used today to create this game is JavaScript. So you can just see the cool stuff that you can make. I mean, this is what you see here on the screen is not even close to what the real game looks like and feels like when you're playing it. So it's extremely powerful, right? Let's see. First icebergs, now lava. Okay, so if you know Minecraft, then you know you don't want to go into lava. You will catch fire. You will be set alight. So get through this volcanic island to find the tropical fish in the coral reef. So there is our goal. Find the tropical fish, and it looks like Nemo, right? So now we need to break this into smaller problems, and we need to look at what our restrictions are. So the first restriction is we can't move over these blocks here. I can't remember what you call them, but they're not good. Okay, so we need to stay in the path. That's the first restriction. The second restriction is we only have 7 blocks in which to complete this puzzle. One has already been used by the when run block. We need the when run block. It's tied to this button, and without it, no code will work. So if we look at this, we can see our first smallest problem is we need to move from here to there. We do not have a repeat by number block, so we need to use a different way to move from here to there. And I want you to tell me in the chat, what block and what type of repeat can I use to get that done? You don't even have to say this block. You can just say move forward, turn left, repeat until goal, if path, your choice. Don't have to type out properly. We're coders. We're not English students here. It's always good to use English, but from coding. So let's just try to get it done. Okay, no one has any idea. So I'm going to help you with this until we have enough students in the classroom to fill up the chat box. Okay. We need to move. So we're going to put a move forward block. That is how easy it is. First problem is move, solution is move. Second problem, how many times do we have to move? Well, we can count 1, 2, 3, 4, 5, 6, 7, and then we can decide if we're going to put 7 move forward blocks down. Then we already have 4, and we're already running out of space. Just continue this, 1, 2, 3, 4, 5, 6, so we need one more. And then you can see If we want to move 7 in this way, it's a problem. We're using more blocks than we are allowed to use. You can see it there, right? So we need to find a different way to move forward. We all know we can use repeats. We don't have a repeat by number, so we have to use this conditional repeat. So what this is saying is until the goal has been met, until this statement is true, this is going to happen, right? Now we know the second problem is we need to turn. We can't just keep moving forward. If we do this, we have the same problem. The boat keeps going into that. And if this is real Minecraft, the boat would have broken because the boats are really flimsy. So we need to be able to turn. We can't just say turn left or right. At the moment we know it's right because we can see it. The orientation is the same as we're viewing the screen, so it's easy to understand. We can't do it this way because then it's going to be move forward one time, turn right. And we're back to that small pattern there. So this is going to go on forever. Or Alex will row off the screen. Okay, she doesn't, right? So we can't do it that way. We can't put this turn right in a specific location because there's no way to tell the code when that is going to be. So what we are going to tell the code is check. You're going to move forward, and once there is an opportunity for you to turn right. Once the conditions are of such a nature that you can turn right, then you turn right. So the code is now actually for every time it's moving forward checking. Over here, can I turn right? No. So I go back to the top of the repeat. I go to the next one. Then after that move forward has happened, check. If you follow my mouse pointer, can't turn right. So we go back to the top of the repeat. And once it gets here, it sees, oh, we can turn right here. So it will do this. If there is a path, then do that. So the statement is true, so that's going to happen. And now you'll see that the solution for this and the solution for the previous puzzle was exactly the same. Different applications, same solution. And we found the tropical fish. Are you guys happy with this? Can I move on? I need a yes from at least one person in the chat box. Great, thank you. Okay, I'm going to run it so we can see it happen. Excuse me. Right, and there we are. Done with this puzzle, so we're moving on. This one becomes tricky. Okay, so we need to focus. We need to take a step back, make sure we follow the problem-solving workflow, make sure we correctly identify the goal, and then we can start with this. So this says you made it to the reef. Now search for the heart of the sea. Use the blue and red coral to reach the treasure chest. So we know now from the way that Minecraft is structured that this heart of the sea is going to be in the chest. So the goal is we need to reach the treasure chest because we know that this is going to be inside that. So if we get here, we have completed the goal. Now this goes one step further, right? So remember, step 1 is identify the goal. Step 2 is break it down into smaller problems and then come up with a solution. So this is actually already giving us a part of one of the solutions. Use the blue and red coral. So we can now already know we're going to have to use these 2 new items to do something. So now we come down to the play area and we see there's blue coral, there's blue coral, there's a red coral, there's a blue, blue, red, blue, blue, blue. Okay. So now we need to look at the restrictions. There aren't many paths that we can use. The green ones that are blowing around, the seaweed that's moving, we can obviously swim past that. The solid ones, we can't swim past that. The solid blocks, we can't swim past that. So that's the restriction in the gameplay. There's also a restriction on the amount of code that we can use. We're only allowed 9 blocks, of which 1 is already used, so we have to do this in 8 blocks. Okay. Right, sorry if I got disconnected there. The next thing is we need to have a look in this toolbox of ours, and we will see that there are 2 new conditional blocks. The one says if standing on blue coral, do something, and if standing on red coral, do something. Okay, so we can assume that something needs to happen every time there is a piece of coral. So first problem first, we need to move from here to there, because that's the first spot where I can see, if you follow my mouse pointer, where we can turn. Okay, we can't go through here, we can't go this way, we can only turn there. So we need to move forward, and we don't want to, again, 1, 2, 3, 4, 5, 6, 7. If we use 7 move forward blocks, we only have 2 left, and we still need to cover all this distance, right? We're not going to do that. So we repeat this. We don't have a number repeat, so we say repeat until goal. Right. Now we've gotten to there. So there are 2 ways you can do this. You can either, I just want to stop banging ahead. You can either try to take your mouse cursor and to solve the problem of the maze, okay? And you can already see a route there that is starting to show. Or you can take one path at a time and just reach your next goal the whole time, right? So we can see here we want to repeat until goal, right? Now this is going to read as an open path. So we can't use an if path to the right, okay? We can only use, oops, sorry. If we use if path to the right, she's going to try and swim in here, and that's not going to work. So what we can do is we can activate the blue coral block. And we can say, right, if you're on this blue coral, we want you to turn right. But now we need to remember, this is going to be true for every blue coral in this puzzle. So we first need to see the route that is going to be traveled if a turning right on this is going to actually help us. So we can see turning right over here, turning right. So we need to go down, obviously, right? So now she's going to hit her head there. Okay. Now we know she has to come this way because it's the only way past. So we can check this blue one turning right is accurate. They will make a plan here. Turning right is accurate. Here turning right is accurate, and there turning right is accurate. So to say as a rule for the entire map, once you are standing on a blue coral, turn right, we can say that is going to work, okay? But here we can see that it's causing a bit of a problem. So we need to do something before she starts hitting her head. The way to do that is to say, if you are on a red coral, because we can see there's a red coral here in line with the blue one there, then we want you to turn left. So now we just need to identify that if all the red corals make Alex turn left, whether we will still get to where we need to be. So checking this one, turning left is going to bring Alex to this blue one. There, Alex is going to turn right because we told the code to do that. Then on this one, she's going to turn left again because that's what we said needs to happen. Then on this one, turn right again, turn right again, turn right again, and go. So in my opinion, this is going to work, and we only used 7 blocks. What do you guys think in the chat? Tell me, can I hit the run button? Yes or no? Okay. Let's test it and see, check it and see. And look at that. And we've done it. Do you need me to explain this again, or can I move on? Yes, yay. Boipele, good. Boipelo, I think. Move on. Okay, if I have one, then I'm great. Let's move on. It's good to have some engagement. Look at this. Look at this. Okay. So if I look at this, it looks scary. If I start by reading the instructions, it becomes easier. There is a squid hiding somewhere in this ocean monument. Can you find it? Okay. So the goal is find the squid, right? That is the goal for this puzzle. And there's the squid. Okay. So now we need to try and break it into smaller problems. Okay. The first problem that I see is the restrictions that we have. We can pass that, but there's no way to come back. We can't turn in here. So there's another maze forming. We can see a maze forming here. Okay. So now we need to also identify the next problem is technically, if we can get Alex here, she can turn down here, but we do not have any sort of conditional block that can force her to turn here. So we need something that we call in coding language a trigger. So we need something where she can stop on that's going to cause something to happen. So they've helped us by saying this is a sea lantern. Now these things here that are emitting light, those are sea lanterns. So we can see that we would be able to trigger something to happen on every sea lantern. So we can see here, if we make a turn right there, she's going in here. There's another sea lantern. So if she turns right again, she can come down here. There's another sea lantern. So turning right is going to put on this sea lantern, and the same thing's going to happen. So we can see that our entire maze is going to run like this. So even though there's nothing restricting her movement here, we are still within the constraint of not having something to force her to turn there, because there is no if path to the right. If we had an if path to the right, we could have made a turn here and then turn left again, or maybe, yeah, turn here and then turn left again. So we can see now what our restrictions are. We have 9 blocks. We need to follow a certain path because it's the only path that'll work. And now we code it. First problem, Alex needs to move. We put a move block. Restriction, 9 blocks. So we can't put 1, 2, 3, 4, 5, 6, 7, and then again 8, 9, 10, 11, 12, 13, 14. We don't have enough space to put many move blocks. So we need to repeat that, and we use the only repeat that we have, which is the conditional repeat. Repeat until goal. Then we see, okay, she's moving. That's a good sign. But now she's going to swim where she's not supposed to go. So we need to stop her from going there. And we do that by saying, if you are on this, I want you to do that. And this needs to set to right. We are orientated the same as she is, so we can see that she has to turn that way. Now, if we run the code, and I am almost run out of time, we can see that that works. Okay, so while that is happening, I'm going to put this for you in the chat box. If you want to copy that, remember, you can keep that link somewhere, and then you can go back to lesson 1 by navigating up here. And then you can play on your own, and please share what you do with me. Okay, so we'll do this one again tomorrow because we haven't completely finished it. You're welcome. Right, so there's my email address. Take it down. I'm going to put it in the chat for you as well. Please feel free to send me your solutions and your things and questions. And then I'll see you tomorrow, where we're going to start with Until Loops in a Maze, but we will first finish Minecraft, okay? And thank you to the STEM Lockdown Digital School. And thank you. Please follow us on these social media handles and use these hashtags when writing about us on social. I'll see you guys tomorrow, and invite your friends to come and join us. It's no fun if the class isn't full. Okay. Have a good day, guys. Bye-bye.